Okay, welcome to the next lesson in complex numbers. Today we're going to look at what's called the rectangular form of a complex number. You may recall in our last video we actually saw some examples that ended up in what we call rectangular form. I even used the term then. The rectangular form of a complex number looks like this right here. You have A, which is a real number, plus B, which remember B is also a real number, but because it's multiplied by J, that part is what we call the imaginary part. So a complex number written in rectangular form actually has two parts to it, or it could have two parts to it, and it basically looks like this right here, A plus B times J. Now remember, A could be 0. 0 is a real number. And in fact, even B could be 0. B is a real number as well. So it's quite possible that if A is 0, you end up with just a number multiplied by J, like for example, 5J. And because this piece doesn't have a real part, we call this a purely imaginary number. But remember, even the B could be 0. So in that case, you have just a real number, perhaps something like 3, but that's still a complex number. You saw in Math 1700 that complex numbers take up all the numbers you've ever seen, purely real, purely imaginary, or some combination of the two. All right, so that's what we call rectangular form of a complex number. Now, one important thing that you need to be able to do with complex numbers in this form is to come up with what we call the conjugate of these complex numbers. And it's very easy to do that. You were actually finding conjugates, you were finding conjugates of radicals back in Math 1700. So for example, you may recall doing something like 1 over 3 plus the square root of 2. All right, you were asked to rationalize the denominator there. And what you would do back in Math 1700 is multiply the top and the bottom by the conjugate of the denominator, which in this case would be 3 minus root 2 divided by 3 minus root 2. And that's what you were doing back in Math 1700. Well, the conjugate of a complex number in rectangular form is basically the same thing. A plus bj has a conjugate of A minus bj. But the thing to remember is the sign of the imaginary part that actually gets changed. So let's look at example number 4 right here. The first number we have, the complex number in rectangular form, is 3 subtract 2j. Well, its conjugate would actually be, simply enough, 3 plus 2 times j. Very easy. Part B, we have a number in rectangular form again, negative 2 plus 5j. Well, its conjugate would be negative 2 minus 5j. Part C, all we have is an imaginary part, 6j. But remember, it's the sign of the imaginary part that actually changes, not the sign of the real part. In fact, you can think of 6j, if you like, as 0 plus 6j. Its conjugate would be 0 subtract 6j, which in fact is just negative 6j. So again, the sign of the imaginary part changed. The last example here is just the number 3. Now it might not look like it, but that's a complex number, and yes, it is in rectangular form, because you can think of that, if you like, as 3 plus 0 multiplied by j. It's a complex number. The conjugate would be 3 minus 0 times j, which again is just 3. So notice the sign of the real part does not change. Practice number 4 on the bottom of page 5. I'm going to leave that for you to try. It's very straightforward. Find the conjugate of each of the following. As you do these, please make sure you keep checking your answers in D2L. The solutions will be posted very shortly. And if you're having any trouble, you make sure you let me know. Now, another thing I'd like to get covered in this video involves certain simplifications involving imaginary numbers. Most of them are relatively straightforward, but there are a few things you really need to be aware of. So let's look at this example here. This is the example on page 6. The first one says, simplify the following. We have the square root of -4, and all of that is squared. Now, we saw an example like this previously. Remember that if you have an expression where you're taking the square root first and then squaring the result, all that happens is that your square root and your squared functions cancel each other out. So the answer here is going to be just -4. If you wanted to do it in a slightly different way, if you actually wanted to evaluate the square root of -4 first, you could do that. And that, in fact, is just 2j. And all of that becomes squared. So 2j multiplied by 2j is 4j squared. Now remember, you're never supposed to leave a power of j in an expression. You could always simplify that. And we saw in one of our previous videos that j to the power of 2 is actually -1. So 4 multiplied by -1, you get -4. Notice you get the same result no matter how you do that. And so whichever way you want to do it is up to yourself. Now B, there's an example where you need to be very, very careful. Because you know that if you have two radicals, and if the indexes are the same, then you're allowed to just multiply them together. However, what you should not do in this case, do not call this the square root of -2 multiplied by -6 becomes +12, and of course that becomes 4 root 3, which reduces, or -4, or sorry, root 4 root 3, so that becomes 2 root 3. That is the incorrect answer. Instead, what you need to do is write each of these numbers first as imaginary numbers. So the square root of -2, of course, you can break that down into the square root of -1 times the square root of 2. So that becomes j root 2 multiplied by. Do the same thing with the square root of -6. Think of that as j times root 6. And now this becomes j squared, and root 6 times root 2 is root 12. Now you can simplify the root 12, but j squared, remember, is -1. So this becomes -1 multiplied by the square root of 12. You can break that down into the square root of 4 multiplied by the square root of 3. So the correct answer, ladies and gentlemen, is -1 times the square root of 4, when that's just 2, multiplied by root 3. So here's the correct answer, -2 root 3. So it's very important to remember how to do examples like that one. If you're multiplying together two square roots of negative numbers, do not multiply the negative numbers first. Change them into imaginary numbers first. Okay? There's two more examples here. C. Now actually, example C, if you look at it carefully, it looks an awful lot like example A, doesn't it? But it's actually a different creature. You're not taking the square root of -7 first and then squaring the result. In fact, what you're doing here for part C is you're squaring the -7 first. So that would actually turn into the principal square root of +49. And the principal square root of +49, 49 is a perfect square. The answer is actually +7. So note the difference there very carefully between examples A and C. And example D, now there's an easy way to do this one and there's a longer way to do this one. The easier way would be to note that you have a square root and a squared function. The square root is being taken first. The result would become squared. So the square root and the square in this case cancels out. All you're going to be left with is -2 squared multiplied by -4. And you can clearly see there's not going to be any imaginary terms left in this answer. -2 squared is +4. +4 multiplied by -4. Your result is just going to be negative 16. Okay? Now, that's the easy way to do it, but if you wanted to, you could have evaluated the terms under the square root symbol first. And let me just show you how that's done. I'll just erase this here. But it's entirely up to yourself how you do these. One thing you could have done first is just call this the square root of negative 2 squared is 4 times negative 4. Well, that's still negative 16 to the power of 2. And the square root of negative 16 is 4j. 4j, well, that 4 looks like a j, doesn't it? Squared. So that gives you 16j squared. And remember, j squared, negative 1. So again, your result is just negative 16. No matter how you do that, that's the result that you will get. So make sure you look over those examples very carefully. Try the questions involving conjugates on the previous page, and I'll end this video here. Our next video is going to be on something called basic operations with complex numbers in rectangular form. We're going to see how to add, subtract, multiply, and divide them. And it's very similar actually to the rules that you learned for radicals back in Math 1700, which is not surprising because remember that an imaginary number, that I, really is just a radical. It's the square root of negative 1. So the fact that the rules are similar shouldn't be too surprising. So I'll stop this video here. The next video will pick up with the basic operations. Okay? Bye-bye.